The atmospheric engine was invented by Thomas Newcomb in 1712. By pumping floodwater from deep mines, steam engines like this set the Industrial Revolution in motion. This example was built by Francis Thompson at Oakerthorpe Colliery, Derbyshire in 1791. It condensed steam to create a vacuum in a cylinder, allowing atmospheric pressure to perform the working stroke.
We chose the engine because it's a, as you know, as you come into the museum, it's this huge beast that sits on, in the corner of our energy hall. It's one of the first things that we see. It's sort of on a monumental scale.
It's massive, isn't it?
Oh, it's huge. Yeah. I think it's something like 20 tons of cast iron and 70 tons of masonry there.
Good heavens!
It's a complete building inside a building.
Yeah,
so it's a good thing to have up there.
What was the technology behind it that was so sort of groundbreaking?
The technology, well, it's an atmospheric steam engine, and it was originally developed by a chap called Thomas Newcomen, who was an ironmonger down in the West Country. But when I say ironmonger, I mean the sort of guy, he's supplying metal wares for mining and that sort of thing, and he becomes very aware of this fact that if you want to get to deep coal reserves a long way underground, you have to remove a huge amount of floodwater first, and that actually doing that was actually probably more of an issue than actually getting the coal up. For every ton of coal you might have 17 or 18 tons of water to remove, otherwise the workings would flood. And so he builds on a lot of work which is happening with people exploring the propulsive force of steam to actually get it to do useful work. And he comes up with around about 1712 this engine, which really is the beginnings of an economy which is built not on organic power sources like wind or water, but on the mineral fuel of coal.
Product of the time. There was a lot happening and a lot of very creative people all looking at similar sorts of problems.
Yes, yeah, absolutely. There's a realisation that steam can be used either by itself, although that presents very considerable technical difficulties, or actually if you condense steam, you create a partial vacuum, which when the atmospheric pressure presses into that vacuum, you get a working stroke and a huge amount of useful work done, and that's what Newcomen's engine does. That's why it's called the atmospheric engine. It uses a vacuum to harness atmospheric pressure.
Were there any drawbacks with this machine that other people were able to sort of understand and then refine and improve?
Problem is, it's enormously inefficient in its use of heat. A huge amount of heat is wasted because every time during the working stroke a lot of heat is pumped in to heat up the cylinder and so on, and as soon as that steam is condensed in the cylinder, all that heat is lost.
Yes,
and that's just a massive waste. So the problem with the engine, although it's good at what it does, is that it can't be used anywhere that hasn't got a very cheap and immediate coal supply to hand.
And then there's the problem of once you've condensed the steam into water, you've got to get rid of that water before you can recharge it.
Absolutely, and these are the issues that start to be dealt with by people like James Watt, particularly afterwards from the 1760s. And what realises is that, well, firstly you can get around this problem of this huge amount of wasted heat, this wasted energy, by instead of condensing the steam in the cylinder, condensing it in a separate condenser, as he terms it. In doing so, you can actually reduce the coal consumption by about 3/4, and suddenly the economics of the engine are transformed.
And so that would then kickstart what we would refer to as the Industrial Revolution.
You get a great diffusion of steam power away from just the mining areas into all sorts of other places, Birmingham, London, the new industrial towns as well.
Oh, and what's really interesting, if you sort of take a step back, the early sort of power sources were water mills. And steam is just water in a different form, and all we're doing is using the same bit of stuff, water, and by changing its state from a liquid to a gas,
it's all very elemental, actually,
yes,
isn't it? There's, I guess in a way, it comes down to very simple, basic, building blocks, and that's quite an appealing proposition, I think.
They were motivated because they saw a commercial opportunity and they reaped the wealth of the Industrial Revolution as a result. That was perhaps driving them. And while we might perhaps look back and slightly disapprovingly on this idea of a consumer culture that just consumed and made money, we can use our fear, if you like, of the future if we do nothing, of the danger to our environment. That drives and inspires us. And certainly as a scientist, you look at the opportunity. And I think human history is full of people who have come up with solutions. And if you sit back and say, there's no hope, And I think a lot of it will actually come from not trying to go off on necessarily a completely wild tangent and do something that's never been done before. It'll be taking something that we understand very well, like steam, and finding new and clever ways to use it to do the sorts of things we need. So I think one can look at the beam engine sitting in the Science Museum and think, well, if they could do that then, imagine what we can do now and what we'll be doing in 200 years.
You come to the museum and you look at this stuff and you see what was done, you see what was achieved and the consequences that flowed from it. Overwhelmingly, I think, positive. We should, take heart from what Watts and Newcomen did with much less than we've got now, and we will get to where we want to be in the future.